Chapter 2. Trace Evidence. Every time you sit on a couch or walk on a rug, you pick up fibers. These tiny pieces of fabric stick to your clothes. Fibers also stick to your shoes and skin. You pick up dirt and grass when you walk across a lawn. You also leave behind hairs and fibers from your clothes. At a crime scene, these things are clues. They are trace evidence. Police carefully search for trace evidence. They bring it to a lab. Scientists there can prove if a hair or a fiber came from a suspect. This will show if the suspect was at the crime scene. It's a fact. Every hour, about 3 or 4 hairs fall from your head. This scientist is looking for trace evidence. Trace evidence in action. Here is how someone might leave trace evidence during a crime. A man walks by a tree. The tree is covered with pollen. The pollen sticks to his jacket. His shoes pick up soil. He enters a house through a broken window. Tiny pieces of broken glass stick to his pants. A hair falls from his head onto the carpet. He sits on a chair. He picks up fibers from the fabric. He leaves fibers from his pants. He leaves pollen from his jacket. Pollen, soil, glass, hair, and fibers are trace evidence. Forensic scientists can use each clue to prove that the man was at the crime scene. Everyday science. Under a microscope, the hairs on your head look different than hairs from other parts of your body. Armpit hairs are oval. Head hairs are round. Eyelashes come to a point at the end. Human hair. Scientists must be able to analyze the trace evidence. This is a microscopic view of cotton fibers. Looking for tiny clues. Police need patience to collect trace evidence. Police often use tweezers. They must pick up tiny hairs, fibers, paint chips, and more. They carefully save the evidence. Back in the lab, scientists study every tiny clue. They use many tools to find out what the clues can tell them. It is important that trace evidence be carefully collected. Special tools. A gas chromatograph, or GC, is a useful tool. This machine tells what chemicals are in trace evidence. First, the GC heats the solid piece of evidence. The solid becomes a liquid. Then it becomes a gas. The GC pushes the gas through a tube. The tube separates each chemical in the gas. If 2 samples have the same chemicals, the samples probably came from the same place. Another helpful tool is a comparison microscope. Scientists use this tool to look at 2 things side by side. Scientists may use it to compare 2 hairs. They use this tool to see if the hairs match. They made a difference. Edmond Locard was born in 1877 in France. As a boy, he loved mysteries. Later, he had the idea that every contact leaves a trace. He meant that criminals always leave trace evidence. They also pick evidence up at the crime scene. This idea is still used in forensic science today. Modern technology helps police in their work. This is a gas chromatograph. Bones. Forensic anthropologists study bones. Bones can tell if a person was male or female. Bones may tell a person's age or height. They can show the cause of death. Bones can even show with which hand a person wrote. Math matters. Here's one way to estimate a person's height from his or her bones. Measure the femur, or upper leg bone, in centimeters. Then multiply by 2.38 and add 61.4. Scientists can gather a lot of information from a pile of bones. One of the first things they do is measure the bones. The shape and size of a bone are clues. For example, a man's pelvis and jawbone are different from a woman's. Bones also have marks. When strong muscles are attached to bones, they leave marks. A left-handed person uses the left side more. Those muscles become stronger and mark the bone. Some bones have breaks or bullet holes. These marks may show how a person died. Teeth can also give clues. Scientists can use teeth to tell a person's age. Careers. Forensic dentist. A forensic dentist studies teeth and teeth marks. Most people get X-rays of their teeth while they are alive. A forensic dentist compares these X-rays to a skeleton's teeth. Sometimes a criminal leaves teeth marks at a crime scene. For example, he may take a bite of food, leaving the rest. If the bite marks are clear, the forensic dentist can match them to a suspect. You can see the hole left from a bullet in this human bone. Forensic art. Forensic artists use a person's skull to find out what he or she looked like in life. They look at the bones. Then they make a sculpture or drawing. Detectives use the art to identify the person. Q&A. Karen T. Taylor has been a forensic artist for more than 20 years. She has done hundreds of drawings and sculptures of crime victims and criminals. Taylor teaches at the FBI Academy. She also wrote a textbook on forensic art. Here's what she had to say about her job. Question: what are some methods you use to make a drawing or sculpture from a skull? Karen T. Taylor: first, I gather all the scientific information. A forensic artist works with forensic dentists, police detectives, forensic anthropologists, and other scientists. I include everything from the crime scene, such as hair, a necklace, or a hat. I use math tables that show average tissue depths. Skin is very close to the bone on the forehead, but down by the cheek it's much fatter. I also use formulas. For example, a relaxed mouth is usually as wide as the front 6 teeth. It's as wide as 8 to 10 teeth if a person is smiling. Question: what would you tell students who are interested in forensic art? Karen T. Taylor: I would tell them that it's not just about art. It's art and a lot of science. This forensic scientist is making a reconstruction of a human face. This facial reconstruction was made from a skull that is hundreds of years old.